Much of our work in mathematics revolves around solving various types of problems. We will be confronted with a particular kind of problem. We will look at what are the characteristics of that problem. We will learn a method for solving, or maybe even multiple methods for solving that kind of problem. And then our job is, as we are confronted with these different types of problems, is to recognize which one we have, match it up to the solution method, apply the solution method so as to get the correct answer. That's really very good practice for certain types of careers. A doctor, an auto mechanic, a computer technician, they all use that same approach in their daily work. They've learned to recognize different kinds of problems. They've learned solution methods, corrective methods for those different kinds of problems. And their job, as they are confronted with them, is to identify it correctly, match up to the method, execute the method, and fix the problem. So when we study math, we're exercising that portion of the brain that functions in that manner. So math is really a very good practice for certain types of work that a person may encounter. I asked you to download a document, and I trust you've done that. And if you look at that document, page 1 of the document, you'll see a number of different kinds of problems. And what we'd like to do is just look a little bit and see if we can identify some of the different groups of problems we have here based upon their characteristics. If we just start with problem number 1, and we look at the characteristics of that problem. It's an equation. It's an equation that only has one variable, and the exponent on that variable is 1. That is what we typically refer to as a linear equation in one variable. If we look down the list of the remaining problems we have here, can you find another equation that has those same characteristics? One variable, and the exponent on the variable is just 1. Well, if we spend a little time looking, we might see problem 6 has those same characteristics, doesn't it? The one thing that's different about problem 6 has fractions where problem 1 did not. Does that change the fundamental nature of the problem, or are they similar problems? Both of them have just one variable, and the exponent on the variable is 1. If we look down a little further, if we look at problem 24 is again an equation, only one variable, and the exponent on the variable is 1. So 1, 6, 24, problem 35 is another example of a linear equation in one variable. Now, we have some other equations in one variable. Problem 4 is an equation in one variable, but the highest power of the variable there is 2. That's a different grouping of equation, and is going to require a different method for us to use to solve that type of equation. That's what's termed a second degree, or also called a quadratic equation. When the highest power of the variable is 2, that's a second degree equation, or what also we call a quadratic equation. As you look down your list, can you find any other second degree, any other quadratic equations in one variable? Can you find another equation where the highest power of the variable is 2? Well, I trust you can see a problem like number 10 is indeed a quadratic equation. We might be tempted to say that number 9 is, but we have to be careful. Whenever we have the variable in the denominator, then that changes the nature of the equation. So even though the highest power of the variable there in problem 9 is 2, we can't classify that as a quadratic equation. We can't classify that as a second degree equation, and that's because the variable with that exponent is down in the denominator, which actually changes the power of the variable. Problems 13 and 14, those are second degree or quadratic equations. In fact, if you look down the list, you find there are a number of quadratic equations here. Look at problem 2. What does problem 2 contain that the other two groupings of problems we've looked at do not have? Well, what should become apparent to you there is we have absolute value signs. Again, you recognize those vertical bars are the absolute value sign. So problem 2 is an absolute value equation, which is going to require a different method of solution than our linear equation in one variable or our quadratic equation. Can you find other examples of absolute value equations? Problem 8 is an absolute value equation, and likewise problem 28. So that group of equations would have its own separate method for solving them. Look at problems like number 3 and 12 and 21 and 31 and 18. Look at what each of those equations possess. They possess a radical sign. In the majority of the cases, it's the square root. If you look at problem 25, 25 has a radical expression in it, but it's the cube root. Now, that would be another family of equations that would require a different solution method. In fact, within that particular family, we might single out a couple of those. If you look at problem 12, we're taking the square root of an expression that has an exponent of 2 in it. Same way in problem 25, whereas the other equations that have radical expressions, the radical expression, the radicand, that's the expression under the radical sign, the radicand, the variable only has a power of 1. We might have to treat problems 12 and 25 differently than we would treat problems 3, 18, and 21. Look at a problem like 9 or a problem like 34. Those are different in that the variable is down in the denominator of a fraction. They're what we typically call rational equations, rational meaning containing fractions. They would have a particular method that we might need to use to solve them. And then, of course, intermingled with all of our problems, we not only have equations, but we have inequalities. Look at problems like 16 and 26 and 32. Those are linear inequalities, and we'll have yet a different solution method that we have to learn. Then there are several that are just kind of oddball problems, like number 7, or even say number 22. Those may have some completely different method again that we have to learn. So one of the things we have to learn to do in math is we have to learn to recognize the characteristics of each kind of problem. How many variables does it have? What's the power on the variables? Is it an equation? Is it an inequality? Are there any other characteristics? Does it have radical expressions? Does it have absolute value? And then we'll have to learn the method for solving each of those groups of problems. And that's what we want to start this quarter looking at here in college algebra. We want to look at these different groups, these different families of problems, equations and inequalities, learn a procedure for solving them, practice that procedure, and then see if we can apply that when we have a mixture of these different kinds of problems.